Hello, another parcel courtesy of banggood.com, and open it up with my little penknife here. I'm going to destroy this table, I think. And we have, there's two items in here. That, I believe, is an oscilloscope, and this is for another day. So, that is an oscilloscope. You have to build it yourself. So I've got the soldering iron ready, and see if I can build it. This is, it's a little digital oscilloscope that you have to put together yourself. And it costs about £15 UK. There's all your components. Oh, some of those look pretty small. It looks like there's some surface mount resistors in there. And that's the screen. So there's the little colour screen, 2.4 inch TFT LCD screen. Very nice. You even get a probe with it. Okay, it's only crocodile clips. It's not a proper oscilloscope probe, but at least they put that in. And it looks on the board, so it's a DSO138. I think that's one of the JTech, or is it JYE Tech? One component is on there. Instruction manuals. How to use? Well, that's if we're successful enough to build it. We'll come back to that one. User manual again. No, I want the building manual. Is there two of these? Oh, there's a little bit of information on the components. And yeah, there you go. So it'll say resistor 1, resistor 14 and resistor 16 is 100k. And then you can sort of just tick off the little boxes as you worked through the components and place them on the board. Now, you can buy this kit that has already got the tiny surface mount device resistors and things already attached to the board. So if you don't want to handle these microscopic components, you can buy the kit, which is, I guess, 13803K. And that way you won't get this extra sheet of paper telling you where to put the surface mount components. So here's the tiny little resistors here, and I just thought it might be handy to let you know how to read these. Now, this first set has 103, first set on this side. What that basically means is there's a 1, then a 0, and then 3 more zeros. So that's 10 /000, so that's 10,000. So that's a 10k resistor. The next one says 332, so that's a 3, another 3, and then the 2 is the amount of zeros again, so that's 3300, so that's 3.3 thousand, so 3.3k. The next one says 152, so that's a 1, a 5 and 2 zeros. You see that end number is just the amount of zeros that you add, so that's 1,500, which is 1,500, so it's 1.5k. The one after that is 102, so that's a 1, a 0 and 2 more zeros makes 1,000, so that's 1k. Now the bottom one's a bit tricky because it ends in a 0. What that basically means is there are 0 amount of zeros that you have to add on the end of it. So 220 means 2, 2 and no zeros. So that's just 22 ohms, or 22R as some people write. Now the great thing is, if you flip it over, you don't even have to worry about all that. But I just thought that might be interesting to show you how you read these surface mount resistors. Now, to put this chip on, the best way to do it really is just put a little bit of solder on one of the end pins. Let's say that one. Just touch it on there. Now, when you get the chip, you can sort of This is very difficult to do. I can't really see what I'm doing very well because the camera is right in front of me. So I'm just going to touch that corner. Now, I solder this one down at this end. Okay, it's a bit of a bodge job, but it is on. I'm going to do another one, just getting it to stay down, stay in place. And it shouldn't move now. Now this is solder flux, so if you make a bit of a dog's ear of it, like I've just done there, believe me, I'm normally closer to the board, so I can solder this much easier. But like I say, I've got a camera stuck right in front of me and I can't actually see what I'm doing very well here. I don't want to keep the soldering iron too long because you can end up actually damaging the component. There you go, that's moved it. And you can sort of just run across the legs. Because I've put the flux on there, you can sort of run across them like so. That one will do. I get the component, sort of line it up by eye. Next up is these tiny little resistors. Oh no, they're just so tiny you can barely see them. Now we've got 23 of these tiny resistors to put on here, and they all look the same, apart from the colour bands of course. But other than that, they're all the same size. The background colour is exactly the same, and they're a bit of a pain to figure out which ones are which. Now there's 23 resistors to go on here, but there's 14 types, 14 different values. And I kind of think instead of going through and trying to sort out all the resistors and do them in the order of what's written on here, I'm going to just use a multimeter. Pick up a resistor, test it, and take its value there, 0.998. Well, that's 1K basically. So I'm going to look on here and see where the 1K resistor goes and just put the 1K resistor in and then do the next and the next and the next until all the resistors have done. So I'm cracking on with all the bits and pieces here now. Get the tactile buttons in. Tick off on the list and move on to the next job. It's all complete now, and what you have to do is set it up and test some of the parts on the board before you put the LCD screen on. In the manual it says put in 9 volts here, so I've got 9 volts going in, it's powered up, and it says test for voltage. Now this is the ground just here, and there's test point 22, TP22 just there, and we want 3.3 volts, or as close as 3.29. That is close enough. I'm quite happy with that. If the voltage at TP22 is good, disconnect the power and short JP4 with solder permanently. Right, JP4 is just there. JP4 is now soldered permanently across there, and then what do? Plug in the main LCD and connect the power supply again, and you should see the LCD light up and the oscilloscope panel displayed. Let's have a go. DSO138. You can verify your kit for authenticity, but this came from Banggood, and I'm told they're all authentic that are there. So there we go. We have the display running. I'll just zoom in.
Oops.
Well, I was kind of hoping it would last a little bit longer than that. So let me just check the actual power that I'm putting in here. This is a reasonably accurate multimeter. 8.91 volts. Well, it's not like I overpowered it. Okay. Right. So what can be wrong with this? I'm going to have to just give it a once over, check all my soldering, and have a look on the forum and see what could be the fault there, because I think I've put it all together correctly. Okay, I've done a few tests. That's on the Jitech website, on their forums, and it seems everything's okay apart from when I get to the 7905, which is a minus 5 volt regulator, and I'm getting sort of really strange voltages crawling out of that. I'm getting minus 15 volts. So I'm going to actually just take that out and see if I can find another one and just replace it. But other than that, what I have managed to do is, if I disconnect this for the moment, when I disconnected it to do some tests, I thought I was going to have to unsolder the jumper number 4, but apparently according to their website you don't. So I plugged this back in, and for some strange reason the display comes up now, but it doesn't go grey anymore. It does actually display the sort of oscilloscope screen, but there's no trace. So it's basically saying if the screen is working and it's running, then the digital side of this is okay. If there is no trace, then the analog side, which is controlled by the 7905, that is not alive, it's not working, which I've done a few tests and I can see that the voltages just are not correct over at the analog side here. So I'm going to change that 7905 and see if that fixes it. But it's a little bit strange that it only lasted 10 seconds before the thing died on me, which is a bit of a shame. Right, that was a bit of a pig to get back off the board. It's not great when you have to unsolder components after only 10 minutes of use. But this is a semiconductor analyzer. Now, it normally doesn't really analyze things like voltage regulators, but it will try and give you a clue as to what it is. It might even come up with it's an LED or it's a diode or something. So let's just test that. So this is the faulty one. Unknown faulty component. Okay. And then we'll put on another 7905 regulator and see what happens here. It's a three-terminal bicolor LED. Well, that's fine. At least it's reading something off that. I know it's not a three-terminal bicolor LED, but according to this machine, it thinks it is. At least it's reading something. So there's a difference. What I'm saying is there's a difference between that one I've taken off and this one. So I'm going to place this one in. Again, this is a 7905, which is a minus 5 volt regulator. A 78 is a positive and a 79 is a negative. And then the next two digits after that, if it's 05, it's 5 volts. If it's 12, it's 12 volts. So right, I'm going to put this one on the board now and see what happens. I don't know. I mean, if this works, I really don't know why that would have just gone in 10 seconds. Oh well. Let's try and get this one on. Put the 9 volts in and see what happens. See how long it stays on for. Ah, now there's a trace. Okay, I'll just zoom in a little bit. So now as you see there, there's an actual trace at last. So yeah, the 7905 regulator lasted 10 seconds and died. Hopefully this is going to last a little bit longer. Maybe it was just a faulty component. It does happen. So don't worry, I doubt that all these are going to leave the factory with faulty components. It's probably just a one-off. But anyway, I've got a trace. That's what's important. Now I can carry on with the rest of the test and set this thing up. That looks more like it. Okay, the big test, put it against a much more expensive oscilloscope, and it seems to be doing pretty well actually. I've got this set to a frequency of 1 kilohertz at 2 volts peak to peak, and on here it says frequency 1 kilohertz. Okay, it's wobbling around a little bit, but it is on here as well. That's just the signal generator that's doing that. But the voltage peak to peak, 2 volts. Flashing around a little bit, but it's actually giving the same sort of results. Now I'll just change a few of the displays. There's the square wave. Unfortunately on the camera you can't see the graticules on this screen. It's probably because of the angle, but everything is measuring up just about the same, exactly the same. There you go. Let me go back to the sine wave for a moment, and I'll change the frequency of this, and I'll double it up, so now it's at 2 kilohertz, and here, yeah, 2 kilohertz. All the same, voltage peak to peak is about the same. This is more steadier on here, but this thing costs many times more. I mean, this thing is only £15, 15 UK pounds. Speed it up a little bit more. Yeah, it's still managing perfectly well. I haven't been through all the settings on this yet, but you can get rid of the information off the screen. To get the information on the screen, you just hold this top button for a couple of seconds and it disappears. There you go, now it runs without it. So just hold it for 2 seconds and there you go. And just press to run and it's running. And it's doing fine. There's lots of these around. If you can, buy it from a proper source, because there's lots of counterfeits. But I checked up my number, which is on the back of the circuit board here, with Jitech last night, and they agree and say yes, this is a genuine board with genuine software running on it, so that's absolutely great. So anyway, so I'm quite happy with that. It seems to be performing reasonably well. Okay, it's not 100 megahertz oscilloscope like that is, but it's fine in the audio spectrum, which is what I'm mainly going to use that for. Maybe put it in a little case and stick it next to a synthesizer so I can visually see what I'm doing. Other than that, yeah, okay, I got a dodgy component with mine, but that's a one-off, I'm sure. And fortunately that happened to me, so I could realise what was wrong with it there. Hopefully you won't get any dodgy components. I mean, they're pretty good sellers, these. There's a lot of them around. A lot of people have avoided on YouTube videos about them, a lot more in depth than I have. And well, that's it basically. If you like that video, please give us a thumbs up, and there's more videos on the way. Thank you very much. Bye bye.